Well, students, good afternoon, and we were doing maximization of revenue, and now we will take up the topic maximization of profit. Now in this section again we will use second derivative test to maximize the profit function. Let x denote the number of units of a commodity produced and p denote the total profit on selling x units of the commodity. Now p is maximum at a point x, for which means when x units are sold, dp upon dx is equal to 0 and d square p upon dx square will be less than 0. In this case profit is maximum, and we already know that p is equal to r minus c, revenue minus cost. Now let's go ahead. Then for maximum profit we should have dp upon dx is equal to 0, or you can also write dr upon dx minus dc upon dx is equal to 0. That is marginal revenue minus marginal cost is equal to 0, or you can say marginal revenue is equal to marginal cost. Hence the necessary condition for maximizing profit is that marginal revenue must be equal to the marginal cost. Now let's do an example and then the things will be more clear. A company has produced X items and the total cost C and total revenue R given by the equation this and this. Find how many items should be produced to maximize the profit. What is this profit? Now given cost function, revenue function, fine. Profit is Rx minus Cx. We already have learned this. Very good. Now after solving we got this equation. Now we found dp upon dx. Good. Then put the value of dp upon dx is equal to 0 and we solved it and we got x is equal to 100. Again doing the differentiation of this, we got minus 0.03, that is already negative. So by second derivative test it is maximum when x is equal to 100, and in the second part he has asked what is this point. So this point will be, put the value of x 100 in the equation of p. This point is rupees 50, means the number of items to be produced to maximize the profit is 100 and maximum profit will be rupees is 50. I hope this is clear. Now let's take one more example. Example number 8, children. A firm has the cost function this and demand function this. Demand function here is this, x is equal to 100 minus p. Now let's take the parts. First part says write the total revenue function in terms of x. Means this will be the independent variable. Okay, so given cost function is this, fine. Demand function is this, fine. But he has asked in terms of x, so we have converted. We have sent p this side and x that side, so it will become p is equal to 100 minus x. So price, this demand function is in terms of x now, fine. Second part says total revenue function in terms of x, revenue function. Now revenue function is x into p, so x and p you already have calculated, so it is here. Now formulate the total profit function p in terms of x. Now total profit in terms of x, so px is rx minus cx. Rx value we have, cx value we have, and we put the values and we solved it. We got this. This is the px. And third part says find the profit maximizing level. So now dp by dx, fine. You solve this quadratic, you got two values, x is equal to 1 and 11. Then you find second derivative, d square p upon dx square, you got this. This time you have got two values to check. First you will keep the value x is equal to 1 in this equation, you got 10 which is greater than 0. And second value you keep 11 and you got minus 10, that is less than 0. So this is the case of maximum when it is less than 0. So at what value it is coming less than 0? At 11. So second derivative test is maximum when x is equal to 11. So profit maximizing level will be what? X is equal to 11. Clear? Example 9, 10, 11, 12, 13, even 14. All are based on the same thing. Now we will come to minimization of cost. Okay, let's take it in the next video. Have a great day.